Hello and welcome to another Ryget Maths video focusing on the second year of the Decision 1 content for the Further Maths A-Level. My name's Simon, and in this video we're going to be looking at how to adapt what you've learned already from the first year Chinese Postman to apply to more than 4 odd vertices in a network or graph. So if you remember, the algorithm that you use is called the Chinese Postman for route inspection. And in the first year, you apply it for networks with exactly 4 odd vertices. Now in the second year, the adaptation for more than 4 odd vertices is not actually that extensive. It's you do a little bit first, and then you do the Chinese Postman as you did in year 1. So the actual content, there's no difference. It's just a little bit first before you do the Chinese Postman algorithm. So we're going to jump straight into an example, and we'll use that to review the Chinese Postman from the first year as well. So this is the example we're going to be looking at, and this is an example from the Pearson textbook. So a night watchman patrolling a number of paths shown in the diagram there, as very typical with Chinese Postman route inspection problems. You're given the network. You're also given the total weight of the network, which is handy because we need that for the algorithm. And we're told a little bit of extra information this time. Now first off, let's think about the odd vertices. Remember, a vertex is odd if it has degree or order an odd number. So we can see all of these vertices, A, B, C, E, F, and G, so all of them apart from D, have odd order. Now the key thing with this is the number of odd vertices is still even. Okay, so the number of odd vertices is still even. If you've got an odd number of odd vertices, it doesn't work. The key thing here that's an extension from what we did in the first year is this. We're given this information here. Now remember, when you have exactly 4 odd vertices, you can find a route that starts anywhere and finishes anywhere. If you have more than 4 odd vertices, you can't do it like that. You have to have a start and finish point. So this will be given to you. Find the minimum time taken to traverse each arc at least once. Again, it means do Chinese Postman. State a possible route. That's a bit annoying because you have to there's no real nice way to do it. It's just look at it and go and figure it out. It's a bit of a pain. And then we've got this extra bit that we're going to have to do on the end. We'll come back to that later. So let's just make a start on part A. So like in the first year, you need to list the odd vertices. So we've got A, B, C, not D, E, F, and G. Yep. So we're told we start at A and finish at C. So we only need to consider B, E, F, and G. So this is really important because we've eliminated 2 of the 6 odd vertices and we've got it down to just 4. Well, now we've got 4 odd vertices. This is just a case of doing the Chinese Postman algorithm as normal. So we list our pairings. I'm going to do those over here. Now, again, your teachers may show you a different layout for this. This is the way I do it, and this is the way I've always done it. I like the kind of spaced layout that mine does, but if you prefer a different layout, as long as you've got all the relevant information, you're absolutely fine. So here are our possible pairings. So we've got B and E, and then F and G, B and F, E and G, B, G, E and F. So exactly like the normal Chinese Postman method. And that's exactly what we're going to do. There's no, this is the extension. This bit here, removing 2 of the vertices. That's the extra bit. Now, it's exactly the same as what you did in the first year. So if we look at B to E, B to E's got lots of different routes, but hopefully you can see that BAE is the shortest one, which is total 20. Now, I like to write the path down, because if we are choosing this pairing, which I can't see if we will or not yet, we don't know. If we do choose this group, it makes it easier to do this. That's the only reason that I write it down. F to G is just F to G. Okay, all other routes take way too far, so I tend not to bother writing it down. And the total for that is 45. B to F, we've got a few options, but we can see that B to C to F, total 29, is going to be the shortest, because this one's 46, then we've got 23 plus stuff, so that's going to be more, 20 plus things, that's going to be more. So we can see that BCF with 29 is going to be the biggest. And then E to G, we can see that this 15 EAG is going to be the smallest one there. Okay, and that totals to 44. As kind of possibly to be expected, the ones that don't have intermediate vertices give us the shorter ones, but not always. So B to G is just B to G, and that's 21. E to F, likewise, just E to F, and that's 15. And this gives us a total of 36. So we repeat B to G and E to F, because those are the ones that are going to give us the smallest increase of time. So therefore, the minimum total time is 154 plus 36, which is 190 minutes. You can see with this one, don't forget the units. Very important for questions of this nature. Don't forget the units. And you might be thinking, well, we ignored A to C. Well, why don't we need to add that on as well? Well, because we are starting at A, we go all the way round, and then we end up at C. Whereas with these ones, we needed to get from B to G and then back again, and E to F and then back again. That's why we repeat them. We don't need to get back from C to A. Okay, we don't need to do that, so we don't need to add anything on at the end. This is our final answer here. Now, stating a possible route, as I said, is a bit of a pain. It's just a case of we're kind of looking at it and figuring it out. So to make this a little easier for ourselves, what's quite useful to do is to add the repeated routes onto the diagram. So we've got B to G, and we've got E to F. Now don't forget, it's very likely in the exam you'll be given this, so just feel free to draw all over it. Now remember, we're starting at A and we're finishing at C. So make sure you are planning ahead. Write A first, down first. So what I tend to try and do is I tend to try and get rid of these repeated routes as soon as possible. So I'm going to go A to B, then B to G, and then back to B. Because that means then I've done both of those and I don't have to worry about it. I've also only got one option from B now, which is to go to C. Now the other thing we need to think about. I'm leaving C on one of these, so I'm going to have to return to C to finish there on a second. Looking at it, this one is probably the easiest to finish on, because there's fewer options. So I'm going to go to F. Now again, I like to try and get rid of these doubles as soon as possible, so I'm going to go to E and then back to F. And then we're very limited in our choices. We've got to go to G, then we've got to go to A, then we've got to go to E, to D, to C, and we're done. Oops. Okay. Now, as I said, this is not a particularly easy thing to do, or at least it's not fast. So it's a bit of a pain, but it's one of those things. It's just, you've got to be able to do it. As I said, feel free to doodle all over the diagram as much as you like to help you with this. Annotate it, cross things off, circle where you're starting and finishing. Because in reality, this is only going to be 1 mark, so you don't want to be spending a ton of time on it. But also, it's quite an easy mark, and you want to make sure you're getting it. Okay, so for this part C, you can see I've just moved a few things around on my whiteboard just to give myself a little bit more space. The only downside of annotating our diagram for part B is usually the best way to do part C and this kind of thing is to annotate our diagram again. So either annotate in pencil and rub it out, or annotate very small so you can annotate again. Okay, so an extra path is included joining B directly to F. Now the key thing here is we're told that a path is included joining B to F. So draw it on and give it a name. I tend to use X. So we'll say let X be the new path, or the length, the weight of the new path. That joins B to F. Okay, just so that it makes our notation nicer. So after the addition of this path, the minimum time required to traverse all of the paths, starting at A and finishing at C. Again, this is important, not really in the grand scheme of things, but it just means we use our answer to part A, because it's the same conditions, is reduced by twice the length of the new path. Calculate the time needed to traverse the new path BF. So the key thing here is now we can see that B and F are even vertices. We're still starting at A and finishing at C, so the only 2 vertices we need to join together are E and G. So B and F are now even. So therefore, only repeat E to G. Now we've seen here that E to G is length 15. So we know that the inclusion of this route, so the total weight that we started with, plus this new arc, plus the repeated, is going to be the total time that we had, and it's reduced by twice the length of the new path. And now this is just an equation to solve. 3x is 190 minus 169, which gives us 21. X is 7. Now don't forget, we have been told to calculate the time needed to traverse the new path BF. Yes, that's what X represents, but we called it X. So we need to make sure that we summarize in context. So therefore, the new path B to F takes 7 minutes to traverse. So again, because students do find this type of thing a little tricky, I'm just going to go through this question again. So this is the original total weight. This is the new total weight. And this is the repeated parts. Okay? This is often, this bit here is what students tend to forget. So go, okay, the whole thing's 169, so 2x is 2x is 21, so x is 10.5. Okay? Don't forget to include this new weight. If you find you're doing a lot of questions like this and you forget, then when you add this new arc here, make a note to yourself that the total weight has changed as well. But again, this is still just an extension to the first year Chinese Postman problems. And that's the nice thing about this topic in the second year, is that this is the only new bit. Everything else you did in the first year. So you can see here, that's the whole of the second year Chinese Postman. Thanks for watching.